All right, piecewise functions. I think the name itself implies that we're taking functions and we're breaking them into pieces. Yeah, perfect. So before we jump into the algebra part of it, maybe let's look at these. You can see that this function here has a beginning and an end, so it's a piece of a function. This one over here is two pieces, right? Right now in my college algebra class, we are graphing things that look like maybe something like this. Oops, there you go. So they can be almost anything. Pieces of functions. And depending on what your domain is, determines what the graph of the function looks like, or the value that you get. So over here in the if x side, right there, that's what you really are going to be paying attention to when we begin to solve for values. Because it says, okay, this is what your function is if your values are equal or less than -2. This is what it is if it's in between these numbers. And it's this constant if we're 1 or greater. And so then I look, and your assignment today is going to ask you to find a couple different values depending on the piecewise function they give you. The first one that we're going to work on is h of 0. Now remember, this is h of x. H of x. So what are they telling you x equals if we've got h of 0? X is 0. So then I look up here in my domain parameters, and I determine which one of those would 0 fit in, top, middle, or bottom. So this is all the numbers smaller than -2. 0 is not smaller than -2. It's the middle one. 0 is in between -2 and 1. Does everybody agree with that? 0 fits in there on the number line. So then I know that I am going to use x minus 1 squared. Minus 1 is my function. And what am I going to substitute in for that x? 0. 0 minus 1 squared minus 1. -1 squared minus 1 is 0. I promise we don't always get the value that we substitute in. Wouldn't that be nice if it was? That'd be a real big shortcut. All right, let's jump over the h of 1, and let's go to h of 3 first. So I look at my domain. Where can x equal 3? Top, middle, or bottom? Bottom. All right, so this one's kind of strange. Is there an x to plug into right here to substitute in for? So this just says h of x is 1. If it's 3 or 4 or 5, any number bigger than 1, guess what our h of x is every single time? -1. And then let's do this one. Let's see. Well, I have h of 1. It's about to write a parenthesis and make a curly h. So I need to determine which one works. One shows up here and here, doesn't it? So how do I know which one to use? It is the bottom one. Do you have a reason?
Because on the middle one, it's just greater. It's just less than, not less than.
Here it's less than 1, and here it can equal 1, right? It can equal 1. And so they'll kind of throw you curveballs like that every once in a while. So when h is 1, that would imply that it is our bottom piece. Therefore, h at 1 is -1. We didn't even have to use that top piece, did we? Let's move over to the next one. Help me visualize or verbalize, I guess, what is going on with that domain right there. What is it telling us? Right, this one is all the numbers except -2. This one, the only value it can equal is -2. All right, so if I've got -4, which one is it going to be? The top one. So let's just say -1/3 times -4 squared plus 5. Remember to do your order of operations. That will get you in trouble today if you don't stay on top of that. And if you don't love fractions, can you use your calculator? For sure. I'm going to change that right now to 15/3. And that would equal then -1/3. Okay, g of -2. There it is, x equals -2 right there. So no math needed this time. What does g of -2 equal? +2, right? And we plugged in -2, and we get h of x, or g of x in this case is +2. And then our last one, g of 4 would again be the top one, the -1/3 one, perfect. -1/3, -2 squared plus 5. So -1/3 times 4 plus 5, -4/3 plus 5. Again, get my common denominator.
No, why did you?
What did I do?
You plugged in -2.
What was I supposed to be plugging in? 4. Because I just wasn't paying attention. Let's fix that, shall we? How'd I do that? Alright, glad you guys caught that. So I'm plugging in 4, right? So that would be a 16. So that would be a -16/3. I don't know what I was doing. And I get a -1/3. Thanks for the save. Okay, the bottom two. We are talking about domain and range. That's what we want to find here, domain and range. So remember, domain is all of the x values, and range is all the y values. What is going to be new and challenging today is interval notation is new for most of you. So I need to take a little detour and talk about interval notation. So you can take notes on the next page in your journal, on the back side of this, whatever makes sense to you. But we're going to talk for just a second about what interval notation means. You guys are very used to seeing maybe something like this. This is set notation. We've got our inequalities, we have values, and we have our variable. Interval notation would look like this. I'm going to do another one, and I'll ask you guys if you can help me determine what on earth is going on over here. And maybe one more. Did I give you, and I know you're screaming to take notes right now, but as you're writing that down, did I give you enough examples to maybe determine what's going on with my parentheses or my brackets over here on the right under interval notation?
Something with your, like, whether you have a bracket or a parenthesis, right?
Yes, yes.
Signs of.
Has everything to do with my signs on the left. Absolutely.
So if you have a greater than, just how you have a bracket.
Perfect. Perfect. So if we have an or equal, Jaden's absolutely right. Those are brackets. If it's not or equal, so if we've got less than or greater than, we've got these, not open circles. I was going to say that next. Parentheses. These would be closed circles on a graph, right? Because it includes the point. It's going to look like I have some crazy creatures going on over there. So far, I've shown you what it looks like when X is in the middle. But is X always in the middle? No, it's for sure not. So what if I have X is greater than 7? I still need to have, like I do right here, a beginning and an ending spot. So this is how we would do it. 7, think of the biggest number you can think of. What is it? Infinity, right? On 7, am I going to have a parenthesis or a bracket? Look at your inequality right there. Parenthesis. Now, can we ever equal infinity? Infinity isn't a value. We can't ever equal it, right? So anytime you have infinity, it always has to have a parenthesis with it. If you put a bracket with it, you get it wrong. Question? No? You just look like you might have a question. Okay, let's go the other direction. X is less than -5. So it's all the numbers smaller than -5. So when it was bigger, I went to positive infinity. So if it's smaller, what are we going to be using? Negative infinity. Now think on your number line. Negative infinity, is it to the left or to the right of -5? To the left, right? So these will need to be in order of your number line. I have one more thing to show you, but maybe we'll wait and do it on your homework problem. Can this disappear for a second? Good. Okay, so domain. Now, I'm not going to write this on my journal page because I want to be able to erase it, but I want to show you what I do. And in fact, when I'm looking on my Chromebook or with you on your Chromebook, I like to have one of the dry erase markers so I can do this if this is something that you struggle with, and then we can erase it. So if I'm talking about the domain, I like to bring this just straight down here. And then I bring this one right here. And now I've got a really good idea of my x values, don't I, if I just connect those dots? So my domain is what? Can't even see what those values are on that board. My domain is in between what? -5 and +5, thank you. Bracket or parenthesis on -5? Bracket, because it is a closed dot, it can equal it. And on 5, what do we have? Parenthesis. Good. All right, let's do that with our range now. All right, so range is all of the y values, right? So I'm going to go to the y-axis this time. There's my closed dot. And there's my open dot. There's my y-axis. Remember, we go least to greatest. So my lowest number is what? Can I equal it? So parenthesis. And my highest value is 4. And I can equal it. It's a little bit. Now, these over here that have multiple pieces are a little bit of an adventure. So let's do the same thing. Let's talk about our domain. Let's see. Domain is X, yes? So closed, open. And I have open and open. And if you're not drawing this on your paper, can you just visually kind of just smash it onto your x-axis, right? So let's see, our domain. We are in between -4 and -2. That one includes it, closed circle. That one is an open circle, whoops, 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 whoops. There we go. And then we have 2 and 5, and they're both open. Now this is, I told you I had one more thing to show you on interval notation, and this is what it is. When I have 2 pieces, we use this symbol. It's a big, tall U, and it stands for union. So it is the union of this piece and this piece. One more. All right. Watch what happens on this one when we're talking about our range. We're here, and we're here, and we're here, and we are here. So look what happens. I've got some overlap, don't I? For sure I have some overlap. So my range only has how many pieces? That's just one long piece because of my overlap. If you do the range of each piece separately, you will get it wrong if there's overlap. So that's kind of why I like to demonstrate that right there. So now that I see the overlap, I can see that I am in between -5 and 3. -5 is a closed dot, 3 is an open dot. Takes a little practice there, but you will definitely get the hang of it. So let me know where you get stuck. Your assignment